Hello friends, today we will discuss about branch and bound technique, and one of the problem based on this branch and bound technique is 15 puzzle problem. So we will cover following things. Basically, what is branch and bound technique? It is very much similar to backtracking, where we generate solution space tree for the given problem. But the difference is branch and bound is used for optimization purpose, whereas backtracking is used for finding out all the possible solutions. So you can say this is one of the comparison point between branch and bound and backtracking. Here similar to backtracking, we'll generate the solution space tree, but in backtracking we generate the solution space tree in DFS manner. But in case of branch and bound, we will generate the solution space tree in terms of breadth first manner. Why it is called branch and bound? As I have told that we generate the solution space tree for the given problem. Definitely we are interested in optimization type of problem. So the name branch and bound is given in the sense that we generate the solution space as a branches of a search tree, and we bound some of the solution by applying some lower or upper bound values. So now we will discuss about one of the problem based on this branch and bound technique. We will consider 15 puzzle problem. So first of all, what is the statement? Problem statement. A 4x4 chessboard is given where 15 numbers are placed. The problem is to arrange number in ascending order. So for a given 15 puzzle, we need to arrange all the numbers for their proper position. As I have told that branch and bound uses the concept of bounding values so that it will be able to reduce some of the solutions which are not giving us optimization values. So we will use cost function. For every problem, the cost function will be different. So we will consider the 15 puzzle problem. Our cost function will be C of x will be equals to g of x plus f of x. We have defined this f of x and g of x. Actually, we are calculating this cost. Why? So that when we generate the solutions in BFS manner, we will discard some of the solutions which are not giving optimal values. This way will reduce the generation of more nodes. This is one of the way where we can say the branch and bound given faster results, faster computation as compared to backtracking. So now we consider this problem where we have given a 4x4 board where 15 numbers are placed. We will be given certain positions of the numbers. The final position will be the numbers will be having its proper position. Just like 1 to 15, we will arrange all the numbers in chronological order. Here, as I have told, that we will generate a cost. We will calculate the cost function. Here, c of x is equals to f of x plus g of x. Where c of x is the minimum cost to reach goal state. What will be the goal state? Goal state means every number is having its proper position. So, for calculation of this cost function, we have taken f of x and g of x, where f of x is simply the number of moves from initial state. I will clear it with solving this problem, taking an example. G of x will be how many numbers are not at their proper position. These are the two factors for calculating c of x. Now we will consider one of the problem based on this. The initial state of numbers will be like this on 4x4 board. So what we can do for this empty block, we will have 4 possibilities. Either we can move down, left, right, bottom. So what we'll do, the movement of this blank square will consider the direction. Like if I will take 3 as down, this blank will move, square will move to upwards. This I have considered it up. The similar way we have considered it down, left and right. So, as I told you, will calculate the cost function at every step and will generate the solution in BFS manner. Here you can see, for this we have 4 possibilities. So, in branch and bound we will generate BFS solution in BFS manner. So, we will generate all 4 possibilities. For this empty block, we will have 4 possibilities of all 4 movements. So, consider this one is the up movement, where what we have done, we have taken 3 as down, and this empty block is moved up. The similar way, down, left and right. So for this up movement, we will calculate the cost. Here C of x will be equals to f of x plus g of x. You can see, from coming this step to this step, we have taken up movement. So how many movement? 1 movement. And then we will calculate what? G of x. G of x is what? How many numbers are not there at proper position? You can see 1, 2, 3 is not at proper position. 1, 4, 5, 6, 7 is not at proper position. 8, 9, 10, 11 is not at proper position. 12, 13, 14, 15. This 12 is also at proper position. You can see 5 numbers are not at their proper position. 1, 2, 3, 4 and 5. So what will be the cost? So cost from reaching from this initial state to next state will be 1 plus 4, that is equals to 5. The similar way we will calculate the cost for all movements. The way we have calculated cost for the up movements. So you can see for down movement the cost will be 1 plus 2, that is equals to 3. For left movement we will have cost equals to 1 plus 4 is equals to 5. And for right movement we will have cost 1 plus 4 is equals to 5. For this first step, you can see all are having f of x value is equals to 1. Why? We have performed only one move from the initial state. So we will have the cost function from up movement is 5, for down movement is 3, for left movement is 5, and for right movement is 5. So here the point of branch and bound has come. We have explored first possibilities in BFS manner. So now I have all possibilities for one movement from the initial state. This is the difference between branch and bound and backtracking, as I mentioned earlier. Backtracking explore DFS manner. So here, as we are using it for optimization, so what we have done, we have calculated all the costs and we have compared that for this down movement, the C of x value is 3. So now we will compare we will choose this node for further exploration. So we will repeat the same thing from this node. Now one thing is important over here. As we have come from this position, from down movement, we will not apply the up movement from here. Why? Because it will lead us to the initial position. So always remember, from a particular state, never when we'll come to a particular state after a movement, never apply the opposite movement. It will take you to the original previous state, and that is useless. So for here, now we have this movement. For this movement, you can see we'll have how many possibilities? We'll have 3 possibilities. Why? We'll not consider up one, otherwise we'll reach to this position. So we have three possibilities: down movement, left movement, and down movement. The same thing will be repeated as we have done in the previous state, and we will calculate the cost function. I am exploring this one. Here we have applied down movements. Now this empty square has come down. So here we will calculate the cost function. So you can see for this movement, as from original we have come with 2 movements. So f of x cost will be 2. Now how many numbers are not at their proper position? So you can see. So how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 is not at proper position. 12 is not at proper position. And 15 is not at proper position. So the Cx value will be 5. The same way we will calculate for the left movement. Here the Cx value is 5. And for the right movement, here the Cx value is 3. So similar to previous step, here again we will calculate we have calculated the cost, and now we will choose this node for the further exploration. Now, as it is the rightmost box, So we are having only two choices left. As we are coming from right movement, we will not go left, otherwise we will reach to the previous position. Further right movement is not possible, so we will have only up and down movements with this. So again we will do the same thing and we will calculate the cost. Here for up movement we will have at third state we have moved 3, third movement is there, that's why f of x for value will be 3. And now for gx value we can see that 8 and 12 are not at their proper position, so gx value will be 5. And now for down movement you can see the f of x value will be 3, but g of x value is 0. Why? After down movement you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All numbers are there at proper position. It means g of cost of gx will be 0. So when you reach to the state where g of x value is 0, it means all the number occupied at their proper states, and that will be our final state. So what we have seen the introduction about the branch and bound. We have taken one of the problem, 15 puzzle problem based on that, and we have seen how the cost function applied to solve this particular problem. Here we have used least cost branch and bound approach for exploration of this solution space tree. Thank you.